Hey there! Imagine an object so dark it completely disappears, losing all depth and dimension. That's Vantablack, a material made of billions of tiny carbon nanotubes that absorbs 99.965% of all visible light. Let's find out why scientists and artists alike are absolutely obsessed with it. Imagine standing in a room where a single object seems to disappear, as if it has been erased from reality. That object is coated in a material called Vantablack, a pigment so dark that it swallows light almost completely. When you look at it, the shape loses its depth and looks like a flat silhouette cut out of the air. This extraordinary effect has captured the imagination of scientists, engineers, and artists alike, turning a simple coating into a window on the extremes of what light can do. Vantablack is not a paint you can pick up at a hardware store. It is made from billions of tiny carbon nanotubes, each one only a few nanometers wide, so small that a human hair is thousands of times thicker. These nanotubes are grown vertically, standing like a dense forest of microscopic needles on a surface. When light hits this forest, it does not bounce back the way it does from a glossy car or a white wall. Instead, the photons travel between the tubes, getting trapped and absorbed over and over again. The result is that more than 99.965% of the visible light that strikes the surface never escapes. In everyday terms, this means that almost none of the light reflects back to your eyes. So, the coated object looks like a hole in space rather than a solid thing. The story of Vantablack began in the world of space science. Engineers needed a material that could prevent stray light from interfering with sensitive instruments on satellites and telescopes. By absorbing virtually all incoming photons, the coating helps instruments capture faint signals from distant stars and galaxies without contamination from reflected glare. Its success in aerospace opened the door to other possibilities, and soon, artists and designers began to wonder what such a dark surface could do in the realm of visual experience. One of the most striking uses of Vantablack is in art installations. Imagine walking into a gallery and seeing a three-dimensional sculpture that appears completely flat, as if it were a painted shadow on the wall. The artist has covered the piece with Vantablack, and because the surface reflects almost no light, the brain can no longer read the usual cues that tell us an object has volume. The edges vanish, the contours blur, and the work seems to float in a void. Visitors often describe the feeling as stepping into a portal, a place where depth ceases to exist. Beyond the gallery, Vantablack is finding its way into technology and everyday life. Camera manufacturers use it to line the inside of lenses and sensor chambers, reducing unwanted reflections that can cause ghosting or haze in photographs. In the automotive industry, designers experiment with dark, sleek finishes that give cars an almost otherworldly appearance. Even fashion has taken note, with daring designers incorporating the material into clothing and accessories. What makes Vantablack so special is not just its darkness, but the way it challenges our expectations. We are used to seeing objects defined by highlights and shadows, by the way light bounces off their surfaces. When that reflection is almost completely removed, our brains have to reinterpret what we are looking at. The effect is both mesmerizing and a little unsettling, because it reminds us that much of what we perceive as solid and tangible is actually a product of light playing tricks on our eyes. Scientists continue to refine the material, exploring ways to make it even more durable and easier to apply to different surfaces. New versions are being developed that can withstand outdoor conditions, opening up possibilities for architecture and public art. At the same time, researchers are investigating similar nanotube structures for use in thermal management, where absorbing light also means absorbing heat, which can be useful in cooling systems for electronics or spacecraft. In the end, Vantablack is more than a pigment. It is a reminder of how a simple change in the way we handle light can transform our experience of the physical world. It started as a solution for space instruments, but its ability to turn three-dimensional shapes into flat, depthless forms has sparked creativity across disciplines. Whether you encounter it in a high-tech laboratory, a modern art museum, or a futuristic car showroom, Vantablack invites you to pause and reconsider what you think you see. It shows that sometimes the most profound visual impact comes not from adding color, but from taking light away. Vantablack truly makes the impossible feel real, turning depth and dimension into pure flatness. If this amazed you, hit like, subscribe, and drop a comment below. Thanks for watching!